Good morning, everyone. This is P. Rajeshwari from the Department of Information Technology, Erode Engineering College. In this session, we're going to discuss about Introduction to Operating System. The contents to be covered in this topic are what is an operating system and its key functions, the evaluation of operating system and its types, basics of Unix and Windows, advantages of open source OS like Linux, network operating system. Before entering into the content, one must know what is a computer system. Computer system is a combination of hardware and software, and a software that has application software and a system software. An operating system is a system software that acts as an intermediary between a user of a computer and a computer hardware. The primary goal of the operating system is to execute user programs and make solving user problems easier and to make the computer system convenient to use. The main goal is to use the computer hardware in an efficient manner. And the structure of computer system. The computer system has four layers. First one is the user, application, operating system and the hardware layer. Each layer is isolated and only interacts directly with the layer below or above it. If we install a hardware device, there is no need to change anything about the application. However, you do need to make changes to the operating system. And also, you need to install the device drivers that the operating system will use to control the new device. Or if we install new software application, there is no need to make any changes to your hardware, but we need to make sure the application is supported by the operating system. The user will need to learn how to use the new application. If we change the operating system, we need to make sure that both the application and hardware will compatible with the new operating system. This is the architecture of the computer. As we know, all the computer is connected to the CPU. The CPU is connected to the northern bridge and the southern bridge. The northern bridge has its RAM and the southern bridge consists of ISA, PCI, USB. Then, as we know, the what is CPU? The CPU is the brain of the computer. It performs all of the calculation. In order to do its job, the CPU needs command to perform and data to work with. The instruction and data travel to and from the computer on the system bus. The operating system provides rules for how that information gets back and forth and how it will be used by the computer. And then about RAM. This is like a disk or a workspace where your computer temporarily stores all of the information and instruction that it is currently using. Each RAM chip contains millions of address space. Each address space is the same size and has its own unique identifying number which we call as the address. The OS provides the rules of using these memory spaces and control storage and retrieval of information from RAM. Device drivers for RAM chips are included with the operating systems. Solve the problem if you know about RAM. If RAM needs an operating system to work and an operating system needs a RAM in order to work, how does your computer activate its RAM to load the operating system? There are two modes in the operating system. First one is user mode and the second one is kernel mode. The user mode deals with the actual interface between the user and the system, and it controls things like running application and accessing files. In this diagrammatic representation, this is the user mode, which is called as the client, and the kernel mode. The user mode is an application interface which consists of a service and the applications. And secondly, the kernel mode is concerned with everything running in the background. It controls things like accessing system resources, controlling hardware functions, and processing program instructions. The kernel mode is also called a server, which has the dispatcher and it connects to the hardware. The system calls are used to change mode from the user to the kernel. Coming into kernel. A kernel is a software that resides in the central core of OS. It has complete control over system. When operation system boots, kernel is first part of operating system to load main memory. Kernel remains in main memory for entire duration of computer session, and it's usually loaded in it to protect the area of memory. The kernel performs tasks like executing, processing, and handling interrupts in kernel space. User performance tasks in user area of memory. This memory separation is made in order to prevent user data and kernel data from interfering with each other. And it does not interact directly with the user, but it direct using the shell and other programs and hardware. This kernel includes the scheduler, supervisor, interrupt handler, memory manager. Scheduler allocates the kernel processing time to various processes, and the supervisor grants permission to use computer resources to each process. Interrupt handler. It handles all requests from the various hardware devices which compete for kernel service. Memory manager allocates space in memory for all users of kernel service. This kernel provides service for process management, file management, input output management, and memory management. The system calls are used to provide these types of services. Next, we are going to see about system call. System call is the programmatic way in which a computer user application requests a service from a kernel of the OS on which it is executed. The application program is just a user process. Due to security reasons, user applications are not given access to privileged resources. When they need to do any input output or have some memory or spawn a process or wait for signal, it requests the operating system to facilitate all these. This request is made through a system call. System calls are also called software interrupts. Okay, here is the clear view of starting an operating system. Power on switch sends electricity to the motherboard on a wire called the voltage good line. If the power supply is good, then the BIOS chip take over. In real mode, CPU is only capable of using approximately 1 ampere of memory built into the motherboard. The BIOS will do a power of self test to make sure that all the hardware are working. BIOS will then look for a small sector at the very beginning of your primary hard disk called MPR. The MPR contains a list of map of all the partitions of your computer hard disk. After the MPR is found, the bootstrap loader follows basic instruction for starting up the rest of the computer, including the operating system. In early kernel initialization stage, a smaller core of the kernel is activated. This core includes the device drivers needed to use computer's RAM chips. Here, BIOS firmware was stored in the ROM or EPROM, which is popularly known as erasable programmable read-only memory. This chip known as firmware on the PC motherboard. BIOS can be accessed during the initial phases of the boot procedure by pressing Del or F2 or F10. Finally, the firmware code cycles through all the storage devices and looks for a bootloader. If the bootloader is found, then the firmware hands over control of the computer to it. Here is another term which it do the same job as the BIOS is UEFI. Stands for Unified Extensible Firmware Interface. But with one basic difference, it stores all data about initialization and startup in an file instead of storing on it on the firmware. This EFI file is stored on the special partition called EFI system partition on the hard disk. This ESP partition also contains the bootloader. It was designed to overcome many limitations of the old BIOS, including to support drive sizes up to 9 zettabytes, where BIOS only supports 2.2 terabytes. UEFI provides faster boot time. UEFI has discrete driver support, while BIOS has drive support stored in its ROM. So updating BIOS firmware it is a bit difficult. UEFI offers a security like secure boot which prevents the computer from booting from unauthorized or unsignal application. This helps in preventing rootkits. UEFI runs in 32-bit or 64-bit mode, where BIOS runs in 16-bit mode. So, UEFI is able to provide a GUI as opposed to BIOS, which allows navigation only using the keyboard. This operating system performs the functions of the process management, memory management, file management, input output management, security and protection, user interface. First one is the process management. It is a process in a program of execution. A process needs certain resources including CPU time, memory, files and input-output device to accomplish its tasks. Simultaneously, the execution leads to multiple processes, hence the creation, execution and termination of a process are the most basic functionality of an OS. If a process are dependent, then they may try to share same resources. Thus, task of process synchronization comes to the picture. If a process are independent, then a due care needs to be taken to avoid their overlapping in memory area. Based on priority, it is important to allow more important process to execute the first than others. The second one is memory management. A memory is a large array of words or bytes, each with its own address. It is a repository of quickly accessible data shared by a computer and I/O devices. Main memory is a volatile storage device. When the computer made turn off, everything stored in RAM will be erased automatically. In addition to the physical RAM installed in your computer, most modern operating systems allow your computer to use a virtual memory system. A virtual memory allows your computer to use part of a permanent storage device as extra memory. The operating system is responsible for the following activities in connection with the memory management. It keeps track of which parts of memory are currently being used and by whom. It divides which process to load when memory space becomes available, and it allocates and deallocates memory space as needed. And then the functions of file management. A file is a collection of related information defined by its A file is a collection of related information defined by a creator. A file system provides the conventions for the encoding, storage, and management of data. In the hard disks such as FAT12, FAT16, F83-2, NTF, EXT3, HFS+. The operating system is responsible for the following activities in connection with the file management. file creation and deletion, directory creation and deletion, support of primitives for manipulation files and directories, mapping files onto secondary storage, file backup on stable storage media. And the fourth is the device management. Device controllers are the components of the hardware motherboard that act as an interface between the CPU and the actual device. The device drivers, which are the operating system software component that interact with the device controllers. A special device called the interrupt controller handles the task of receiving interrupt requests and prioritize them to be forwarded to the processor. And then the deadlocks. Deadlocks can never occur when two or more processors have control of different input output resources that are needed by the other processors and they are unwilling to give up control of the device. This performs the activities like keep tracks of all devices connected to system, designate a program responsible for every device known as input output controller. It divides which process get access to a certain device and for how long, and it allocate devices in an effective and efficient way and deallocate devices when they are no longer required. And then the security and protection. The operating system uses password protection to protect user data and similar other techniques. And it also prevents unauthorized access to programs and user data by assigning access right permission to files and directories. The owners of information stored in a multi-user or networked computer system may want to control use of that information. Concurrent process should not interfere with each other. And then the user interface mechanism, which is similarly called as UI. It controls how you enter data and instruction and how the information is displayed on the screen. There are two types in it: command line interface and graphical user interface. The command line interface is a type command represented by short keys or abbreviations or presses special keys on the keyboard to enter data and instruction. This is the example of command line interface. And these are the command prompts. And these are the commands entered by the users. And these are the command prompts. And then second one is graphical user interface. With the graphical user interface, you interact with the menus and visual images. Okay, now we will see about the history of operating system. The first generation of operating system is in between the 1960s, 1940s and 1950s. There is no operating system. All programming was done in absolute mechanism language, often by wiring up plug ports to control the machine's basic functions. And then the second generation is in the year between 1955 to 1965. The first operating system was introduced in the early 1950s and it was called as GMOS, created by General Motors for IBM's machine, the 701, single stream batch process system. The third generation. The third generation is introducing of multi-programming and the development of many computers. And the fourth generation developed PCs and then the birth of Windows or Macs are popularly accessed in this generation. There are various types of operating systems. Nowadays we are popularly using the Windows and some other else. Let me discuss about that. Batch operating system, multi-programming operating system, time sharing OS, multi-processing OS, distributed OS, network OS, real-time OS, embedded OS. Okay. Batch processing was very popular in 1970s. The job were executed in batches. People used to have a single computer known as mainframe. Users using batch operating system do not interact directly with the computer. Each user prepare their job using an offline devices like a punch card and submitting it to the computer operator. Jobs with similar requirement are grouped and executed as a group to speed up processing. Once the programmers have left their programs with the operator, they sort the program with the similar needs to the batches. The batch operating system grouped jobs that perform similar function. These jobs groups are treated as a batch and executed simultaneously. A computer system with this operating system performs the following batch processing activities. A job is a single unit that consists of a present sequence of commands, data, and program. Processing takes place in the order in which they are received. That is the first come, first serve. These jobs are stored in memory and executed without the need for manual information. When a job is successfully run, the operating system releases its memory. There are two types in this batch operating system. The first one is simple batch system and the second one is multi-programmed batch system. The advantages in this batch operating system is the processor of the system know how long the job would be when it is in queue. Multiple users can share the batch systems. The idle time for the batch system is very less. It is easy to manage large work repeatedly in batch systems. The disadvantages of this are the computer operators should be well known with the batch systems. Batch systems are hard to debug. It is sometimes costly. The other jobs will have to wait for an unknown time if any job fails. The example of batch based operating systems are IBM's MBS and then multi-programming operating system. Multi-programming operating system. As the name suggests, multi means more than one and programming means the execution of the program. When more than one program can execute in an operating system, then this term is called as a multi-programming operating system. The major task of the multi-programming is to maximize the utilization of the resources. Multi-programming is broadly classified into two types: multi-user operating system and then multitasking operating system. Multi-user and multitasking both are different in every aspect of multitasking in an operating system that allows you to run more than one program simultaneously. The operating system does this by moving each program in and out of the memory one at a time. When a program runs out of a memory, it is temporarily stored on disk until it is needed again. A multi-user operating system allows many users to share processing time on a powerful central computer on different terminals. The operating system does this by quickly switching between the terminals, each receiving a limited amount of CPU time on the central computer. Multi-programming operating system use the mechanism of job scheduling and CPU scheduling. And then the time sharing operating system. In this operating system, each task is given some time to execute so that all the tasks work smoothly. These systems are also known as multitasking systems. The task can be from a single user or different user also. The time that each task get to execute is called quantum. After this time interval is over, OS switches over to the next task. Time sharing operating systems. The advantages of time sharing OS is it in each tasks get an equal opportunity, fewer chances of duplication of software. CPU idle time can be reduced. The disadvantages which includes reliability problem, one must have to take care of the security and integration of user programs. The data communication problem arises. And then the example of time sharings are the Multics, Unix, etc. And the multiprocessor operating system. Multiprocessor operating system, also known as parallel OS or tightly coupled OS. Such operating systems have more than one processor in close communication that share the computer bus, clock, and sometimes memory and peripheral devices. It executes multiple jobs at the same time and makes the processing faster. It supports large physical address space and large virtual address space. If one processor fails, then the other processor should retrieve the interrupted process state. So, the execution of process can continue. Inter-process communication mechanism is provided and implemented in hardware. And distributed operating system. Various autonomous interconnected computers communicate with each other using a shared communication network. Independent system possesses their own memory unit and CPU. These are the independent system. It possesses the own memory unit and CPU, but shared using a communication network. These are the referred to as a loosely coupled system. Examples are Locus, DYSAC, network operating system. These systems run on a server and provide the capability to manage data, users, groups, and security applications and other networking functions. These types of OS allow shared access of files, printers, security, application, and other networking functions over a small private network. The other computers are called client computers, and each computer that connects to a network must be running client software designed to request a specific service, and it is popularly known as tightly coupled system. The advantages of network operating systems are it is highly stable centralized service. Security concerns are handled through service. New technologies and hardware upgradations are easily integrated into the system. Server access is possible remotely from different locations and the types of systems. The disadvantage of network operating systems are these servers are costly. User has to depend on a central locations for most operations, and the maintenance and updates are required regularly. The network operating systems, and that we popularly know Microsoft Windows Server 2003, 8, 2012, and then the Unix, Linux, Mac OS X, Novel, NetWare, and BSD, etc. And the real-time operating systems. These types of operating systems serve real-time systems. The time interval required to process and respond to input is very small. This time interval is called the response time. Real-time systems are used when there are time requirements that are very strict like missile systems, air traffic control systems, robots, etc. There are three types in this real-time operating systems. First one is hard real-time operating system. These operating systems guarantee that critical tasks be completed within a range of time. For example, A robot is hired to weld a car body. If the robot welds too early or too late, the car cannot be sold. So it is hard real-time system that requires complete card welding by robot hardly on the time. Specific experiments, medical imaging systems, industrial control systems, weapon systems, robots, air traffic control systems, etc. And then the second one is soft real-time operating system. This operating system provides some relaxation in the time limit. For example, multimedia systems, digital audio systems, etc. Explicit programmer defined and controlled processes are encountered in real-time systems. A separate process is changed with handling a single external event. The process is activated upon occurrence of the related event signaled by an interrupt. Multitasking operation is accomplished by scheduling processes for execution. Each process is assigned a certain level of priority that corresponds to the relative importance of the event that it serves. The processor is allocated to the highest priority processing. This type of schedule, called priority based preemptive scheduling, is used by real time systems. And then the third one is firm real time operating system. Real-time operating systems, shortly known as RTOs, of this type have to follow deadlines as well. In spite of its small impact, missing a deadline can have unintended consequences, including a reduction in the quality of product. Example, multimedia application. The advantages of this real-time applications are maximum consumption. It utilizes of devices and systems, thus more output from all the resources. Task shifting. Time assigned for shifting tasks in the system is very less. For example, in older system it takes about 10 microseconds shifting one task to another, and in the latest system it takes 3 microseconds. And focus on applications, a real-time operating system in embedded system, error-free memory allocation. These are the major advantages of this real-time operating system RTOS. The disadvantages are limited tasks. Only a few tasks run simultaneously and their concentration is very less. And few applications to avoid errors. Use heavy system resources, complex algorithm, device drivers and interrupt signals, thread priority, minimum switching. And then the embedded operating system. An embedded operating system is one that is built into a circuitry of an electronic device. Embedded operating systems are now found in automobiles, barcode scanners, cell phones, medical equipment, and personal digital assistants. The most popular embedded operating system for consumer products such as PDAs, including the following: Windows XP Embedded, Windows CE.NET, which support wireless communication, multimedia, and web browsing. It also allows for the use of smaller version of Microsoft Word, Excel, and Outlook. Palm OS. It is the standard operating system for Palm brand PDAs as well as other proprietary handheld devices. Symbian OS found in smart cell phones from Nokia and Sony Ericsson. There are popular types of OS that are using in the desktops are Windows, OS X, Unix, Linux, Chrome OS, and then the server class are Windows Server, Mac OS X Server, Unix or Linux. In the mobile class, Android, iOS, Windows phones. These are the most popular types of OS. The desktop class operating systems. Platform. The hardware required to run a particular operating systems are the Intel platform, which is the IBM compatible. The Intel platforms are Windows, DOS, Unix, Linux, and Macintosh platform, Mac OS, iPad, and iPhone platform. These are the platforms that are operating in the desktop side. And MS-DOS, single user, single task OS. It had no built-in support for networking and user had to manually install drivers anytime they added a new hardware component to their PC. DOS support only 16-bit programs, command line user interface. So, why is DOS still in use? Two reasons are its size and simplicity, and it does not require much memory or storage space for the system, and it does not require a powerful computer. And coming into Microsoft Windows, I think uh, everybody have an idea about this Microsoft Windows because it was in a because it was used by many people. The graphical Microsoft operating system designed for Intel platform desktop and notebook computers. It is best known greatest selection of applications available. Current editions include Windows 7, 8, 8.1 and 10. Nowadays also the 11. And then the Mac OS. Mac OS previously known as OS X. It is the operating system developed by Apple for its Mac line of personal computers and workstations. The abbreviation of Mac OS is Macintosh. It was first introduced in 2001 as the successor to the classic Mac OS. Since then, it has undergone many updates and improvements to become the sophisticated and user-friendly operating systems. Mac OS is built on a Unix-based architecture and provides users with a stable, reliable, and user-friendly experience. The operating system is designed to be intuitive and easy to use, focusing on simplicity and elegance. The user interface of macOS is clean, organized, and aesthetically pleasing, making it a pleasure to use both the casual and professional users alike. In addition to the sleek design and user-friendly interface, macOS is also known for its stability and security. With its robust security features, the operating system helps to protect users' data and privacy, making it a popular choice for individuals and organizations. The current editions include Sierra, High Sierra, Mojave, Catalina, and Big Sur version, which is released in November 2020. The advantages of macOS are streamlined user interface, hardware and operating system integration, the security integration with Apple devices, multitasking, free productivity application, good customer support, consistent graphic user interface, long life, etc. The disadvantages of this OS are it is high cost, limited software availability, lack of customization for hardware, incompatible file system, lack of flexibility for upgrading hardware, high cost of Mac based product. And open source, the Linux is an open source cross platform operating system that runs on a desktop, notebook, tablets, and smartphones. The name Linux is a combination of Linus, the first name of the first developer, and Unix, another operating system. And just like Windows, iOS, and Mac OS, Linux is an operating system. In fact, one of the most popular platforms on the planet. Android is powered by the Linux operating system. An operating system is software that manages all of the hardware resources associated with your desktop or laptop. To put it simply, the operating system manages the communication between your software and your hardware. Without the operating system, the software wouldn't function. The users are free to modify the code, improve it, and redistribute it. The developers are not allowed to charge money for the Linux kernel itself, but they can charge money for distributions. These are the features of Linux operating system. And then coming into Google Chrome. Chrome OS, it is a popular thin client operating system. A thin client in a computer with minimal hardware designed for specific tasks. For example, a thin web client is designed for using the internet. This is also a Linux based operating system developed and designed by Google. It is derived from the open source Chromium OS and uses the Google Chrome web browser as its principal user interface. Google announced the project in July 2009, initially describing it as an operating system where the applications and user data would reside in the cloud. Chrome OS were used primarily to run web applications. All Chrome OS and Chromium OS versions support progressively web applications as well as web browser extension. Chrome OS from 2016 onwards can also run Android applications from Google Play. Since 2018, Chromium OS version 69 onwards also support Linux applications which are executed in a lightweight virtual machines with the Debian environment. The applications of Chrome OS was, as we know, the Chrome applications like that. Server operating systems. There are three kinds in it: Windows Server, Unix Server, and Linux. Windows Server, familiar graphical user interface for those experienced with Windows. Unix is a very mature server capabilities, time tested, large user community, and stable. Linux is a free, customizable, many free services and utilizes available. Okay, Windows Server. Windows Server is a line of Microsoft operating systems comprised of extremely powerful machines. Windows Server was first launched in April 2003. It is typically installed on heavy use servers, serving as a backbone for most IT companies, applications, and services. The server handles the administrative group related activities on a network. It organizes, stores, sends, and receives files from the devices connected to network. Windows Server versions. When it comes to networking, Windows Server has become the standard. For the last 16 years, Microsoft has released a major version of Windows Server. Every 4 years, a minor version every 2 years, and a minor version with every 2 years. The minor version can be recognized with the suffix R2. The Windows operating system is persistently updated to add new functionality to match the needs of today's users. Administrators need to understand how their service has evolved and upgraded. The list of all major and minor Microsoft Windows services versions is as follows: Windows Server 2000, 2003, 2008, to, 2008 R2, and 2012, 2012 R2, and 2019. These are the versions of Windows Server. And then the Unix. The Unix is a powerful operating system initially developed by Ken Thompson, Dennis Ritchie at AT&T Bell Laboratories in 1970. It is prevalent among scientific, engineering, and academic institutions due to its most appreciative features like multitasking, flexibility, and many more. In Unix, the file system is a hierarchical structure of files and directories where users can store and retrieve information using the files. The features of this unique operating systems are multitasking, command structure, file security and protection, communication, accounting, unique tools and utilities, open source, portable, and multi-user. There are three layers in this Unix: hardware, kernel, tablet and phone operating system. System on chips, an operating system that comes pre-installed on a chip, is a portable device such as a smartphone. Popularly, system on chip operating systems are iOS, it's for iPad and iPhone, and Android for varieties of tablets and phones. Downloadable applications from an app store, for example, Apple App Store, Google Play Store. iOS on the iPhone and iPad. The Apple created operating system for Apple tablets and phones. The current stable version iOS 14 was released to the public on September 16, 2020. And Android. It is a popular OS for smartphones and tablets. It's based on the Linux kernel. It was developed by Google. The current versions of Android include Android 8 Oreo, Android 9 Pie, Android 10, and Android 11. And the advantages of Linux operating systems are it is open source. As it is open source, its source code is easily available. Anyone having programming knowledge can customize the operating systems. One can contribute and modify the code for any purpose. And the second thing is the security. The Linux security features is the main reason that it is the most favorable option for developers. It is not completely safe, but it is less vulnerable than others. Each application needs to authorize by a admin user. Linux system do not require any antivirus programs. It is free. Certainly, the biggest advantage of Linux system is that it is free to use. We can easily download it and there is no need to buy the license for it. It is distributed under GPL, General Public License. Comparatively, we have to pay a huge amount for the license of the other OS. And it is lightweight. The requirement for running Linux are much less than the other operating systems. In Linux, the memory, footprint, and disk space are also lower. Generally, most of the Linux distributions require as little as 128 MB of RAM around the same amount of disk space. Stability. Linux is more stable than other operating systems. Linux does not require to reboot the system to maintain performance level. It rarely hangs up or slows down. It has a big uptimes. And the performance is very high over different networks. It is capable of handling a large number of users simultaneously. It is very flexible and can be used for desktop applications, embedded systems, and server applications too. And it also provides various restriction options for specific computers. We can install only necessary for components for a system. The software updates. In Linux, the software updates are in user control. There are a large number of system updates are available. These updates are much faster than other operating systems. So the system update can be installed easily without facing any issue. And then the distribution. There are many Linux distributions available in the market. Provides various options and flavors of Linux to the users. We can choose any distros according to our needs. Some popular distros are Ubuntu, Fedora, Debian, Linux, Mint, Arch Linux. For the beginners, Ubuntu and Linux Mint would be useful. Live CD or USB. Almost all Linux distributors have a live CD USB options. It allows us to train or run the Linux operating system without installing it. Graphical user interface. Now, Linux is a command-based OS, but it provides an interactive user interface like Windows, and it is suitable for programmers. It supports almost all of the most used programs. Most used programming languages such as C++, Java, Python, Ruby, and more. Further, it offers a vast range of useful applications for development, and the programmers prefer the Linux terminal over the Windows command line. It also provides the support for SSH, which helps in managing the server quickly. Community support. Linux provides us large community support. We can find support from various sources. There are many forums available on the web to assist users. Further, the development from various open sources communities are ready to help us. And it has a privacy over the users. Linux always take care of the user privacy as it never take much private data from the user. And in the networking, it facilitates with a powerful support for networking. The client server system can be easily set to a Linux system. It provides various command line tools such as SSH and the compatibility with a large number of file format as it supports almost all the file format. The installation takes less time than other operating systems such as Windows. Further, its installation process is much easy as it requires less user input. It does not require much more system configuration. Even it can be easily installed on old machines, having less configurations. The multiple desktop support can be accessed using this Linux operating system. Multitasking operating systems as it can run multiple tasks simultaneously without affecting the system speed. And it is heavily documented for beginners. The Unix shell and utilities. The shell used to be in the kernel, but now is a utility over outside of it. Easy to change or debug. Many of them SH, PSH, CSH, TCSH, WSH, bash. Possible to switch between them. And it is a very simplified shell, which example is given in this slide. The summary of this operating systems are the operating system, its history and the types, operating system structure, and about the parts which are used in this operating system, and the functions, the advantages and disadvantages of all the topics are covered in this session.